Okay, this is another set of exercises on PySpark. We're going to be dealing with collecting and exploiting sets or lists on the Spark. The first exercise is collect all products per order using collect list. So we're grouping by order and we're making collect list of product IDs existing in this in each specific order. Also, there is additional count of number of products ID, and we are sorting by number of products in the order. Okay, by default, we see this picture that certain product IDs in this amount exist in this order. This is filtered to see instances with less amount of product IDs, 12 product IDs per order in these orders, and this is equivalent in in Spark SQL. So we group by order ID, we do collect list, we do count, we have order, and we sort by num product IDs in descending order. So you see this order ID here corresponds to this one. This collect lists is this one, this count is this one, and this order by is this one. This from is simply this one, this order by here, group by here. So so this result, the first one, and this result is a query, they are identical. The first and the third one. This one and this one. They are done in different ways, but the result is the same. The query plan is the same. Okay, collect unique product IDs per order using collect set. This is basically similar as previous, but the products are unique. They should not be repeated. So the same thing, group by order ID, collect set unique, count distinct product IDs should correspond to the length, and this is alternative way of making count. We can collect set and take size of it. It's still equivalent. You see, in both cases we have collect set, and here we have count distinct of products. Here we have size of collect set, which produce the same result. It's another question which is faster. I will probably run some tests to check it. However, the results in all four cases are the same. Okay. Let's collect array of product names per aisle. So we are collecting product names and grouping by aisle. So first we do join products by aisles, then we group by aisle ID. Grouping by aisle name is not that optimum, and then we do collect list of product names. And here we see similar picture, but here the names are collected. These are not unique names, therefore, because it's the collect list. Collect departments used by each user. So departments are sections of products purchased, and we have to make join and then group by user ID. So we join orders on orders prior, we join them on products, the products exist in order prior. This is basically order header. These are order lines. Then we join by department. Department exists in product. And we group by user. User exists in order. So we have taken order from orders, and we have taken department ID from departments, and we made collect set. So these are unique departments or areas of products for each user. Exercise 5. For each product, collect all add to cart positions. Oh, this is a strange exercise. How many positions in checks each user had? So basically, how many of these positions? I added array sort, which sorted positions by ascending order. Okay, and here we have these check positions. Strange thing is that they do not go sometimes in sequence. They have gaps in them. No matter how it's explained, this is not a straight sequence. Collect all aisles names per department. So they have sections called aisles, and we have areas of products called department, and we need to collect the unique aisles per department. So we simply need to do join aisles on products, products on departments. Basically, products comprise many-to-many between aisles and departments, and then we do collect set. And each department has certain number of aisles in them. Okay, exercise 7. Create an array of order hour of the day for each user. So we want to collect unique hours of the day when user was making purchase. So again, group by user ID, array sort of collect set, and this is order hour of the day for user. So we can tell that user number 1 has been making purchases at these hours, and this user number 4 is used to make purchases at this number of hours. For each order, collect reorder flag in array. So reorder flag is if something was reordered, so basically group by order ID, collect list reordered. The list is not unique. Okay. Per aisle, build array of distinct product IDs ordered in prior data. So we take prior data, we join on products, we join on aisles, we group by aisle, and we do collect set of products. And here we have it, aisle ID and collected list. Create an array of eval set values per user. Task: use orders. User may appear in multiple eval sets. Okay, eval sets are different sets of orders. This is called prior train test. So basically, to make a story short, there are 3 sets of orders, and we check if user appears in any 3 of them. So user number 1 appears in these 2, user number 4 appears in these 2. And this was done by collect set. Okay, next set of exercises is exploiting the collected list. So we first collect, and then we uncollect it, explode it into individual lines. So first aggregate product IDs into array. So we aggregate product IDs. So we aggregate by order ID, and we collect product IDs. We collected them, and then we can explode them. So we have order ID, and we have exploded product IDs. So for each order, we have exploded its product IDs. Basically, we return to the same structure as they existed in prior. Okay, explode distinct aisles purchased for each user. Build an array of aisles names per user, then explode them. This is more sensible task. We go through orders, we join them on products, we join them on aisles, we group by user, and we collect aisles. And this is unique set. And then we explode, and we have aisles exploded for each individual user. So I have added more lines, and here we can see that there are a number of aisles per each user ID. Okay, and this is for each user ID, and here is the second set and goes down. Okay, third thing, posexplode product name arrays. Posexplode does the same thing as explode, but it also adds position number. For each aisle, create an array of product names and use explode so each row shows index product name. So we joined products with aisles grouped by aisle ID, collected list of product names, and then we explode them back. So so you see aisle ID, and here are product names, and they are exploded in ordered fashion. I have added more lines, but there are actually many positions, so they can go down the bottom. Explode are hourly order activity per user. Group orders by user, collect list of order hour of the day, then exploit into 1 hour per row. We have done this grouping, so we collect list, and then we collect list order hour of the day by user ID, and then now we explode it back. So this is this function, this field of collected list. We explode it as hour, and here is user ID. So user ID hour, and we have each user and its hours. Okay, convert reordered flag array. 2 rows for each product, collect reordered flag from prior data, then explode back into rows. So we collect lists by grouping product IDs, then we explode them back, and we have product ID reordered or not reordered, and this is not unique list, therefore the values repeat. Explode combined array of aisle plus department per product. Create an array column containing aisle department ID for each product. Then explode into 2 rows per product. Okay, here we create we group by 2, basically. We group 2 values per 1 product, and then we explode them back. We have we're not doing any grouping in the original query. We're collecting an array of 2 fields, aisle and department, and then we explode them with the position into 2 lines. One line corresponds to product, another line corresponds to aisle or department. So 0 position is aisle, first position is department, same here. So we basically pivoted, or better say, yes, we have pivoted these 2 fields vertically, pivoted. Okay, explode array of daily orders for each user. So we collect set of orders day of the week per user, and then we explode it. So here we do group by user ID, collect set by order do, and then we explode it from user ID, user day of week, alias do. And you can see this is user 1, and he made purchases in the past on 4 days of week, and this were exploded back into lines. Exploded product arrays per department. Join products department, group by department, collect list product ID, then explode. So we have joined products with departments, group by department ID, collected list. Then we explode product IDs by department. So department product ID, department product ID. These two combinations which exist as many to many we have collected and then exploded it. Posexplode add to cart order positions per order. Build array of add to cart order for each order. Then posexplode. Basically, we're doing grouping of order to cart order by order ID. Then we explode it back, and we have order ID add to cart order in an exploded way. Okay, next thing, explode combine array product name aisle department. So we do the combined array of these three. For each product, construct an array of all three strings, then explode, so each becomes its own row. So we have to do this. We put 3 fields into one array, and then we are exploding them into the individual line. So these are 3 IDs, and this is posexploded array. So you see department ID, aisle ID, product ID, and this one we have position. This is product name, this is aisle name, and this is department name. Again here, this is product name, aisle name, department ID, and all 3 IDs are the same. Basically, this combination of 3 of them persists across 3 rows, and these under different positions 0, 1, 2 we have these field names. Okay, next, assuming count how many orders exist per eval set. So we went on to grouping exercises. So we do group by eval sets and aggregate count and aggregate distinct orders. And here we have it. Eval set, prioritize, train, count, number of orders. I will continue grouping exercises in another video. So let's finish at this point.